Okay, so we were discussing the refrigeration cycle. Okay, so we said the idea is to uh, operate the fluid in a cycle to, in order to force it, let's say, to take heat from the position in the position and I want, and to reject heat in the position I want. So in this case, okay, whenever I want to produce cooling effect in my room, I will put my room should be in the side of the evaporator, because at the evaporator side, the fluid that is circulating in my system will take heat, while at the condenser side, it will reject heat. Okay, and in general, in evaporator and condenser, we have mixture, we have two phases. This is why we'll introduce in this chapter how we deal with phase change, how to get properties during phase change. Okay. Uh, and now, whenever I exit my condenser, the pump is here to be able to repeat the cycle, because it will allow me again to go from the low pressure at the exit of condenser to a high pressure at the inlet of my evaporator. And this cycle will be repeated. Now, in case I need to produce heating effect, my room should be from the condenser side. Okay, and then the evaporator will be from the outer side. Okay, so I can, by just putting work, so here I am putting electrical work to operate my pump. By providing work, I forced heat to go in a non-conventional way. It will go from low temperature to high temperature, while if I leave it to nature, it will always go from high to lower temperature. Okay, now let's say I want to study efficiency of this system. I should determine if I am studying the cooling efficiency or the heating efficiency, because if I want to produce cooling, okay, so let me put it again in this way. Okay, if I want to produce cooling effect, what I care for is the heat that is rejected from the room. I said that if I want to produce cooling, I should put the evaporator from the side of the room, because the evaporator, the fluid will take heat from my room. So what will be important for me then in cooling is Qn. I want to extract heat from the room and give it to the fluid. Okay? And to do this, I need to operate my pump. So what is the work I am putting? It is electrical work, W electrical. So if I want to study the cooling efficiency, we call it here, we talk about coefficient of performance. And the coefficient of performance can be larger than 1. We'll discuss this now. The coefficient of performance during cooling will be Qn, which will produce the cooling effect because I'm extracting heat from my room, over the input. What is the input I am using here? It's W electrical.
Work of the compressor.
Work of the compressor, exactly. While if my purpose is to heat the room, okay, then I should put the room to the side of my condenser. This is why your HVAC system can operate in both conditions. Just what it will do, it will switch if you want the cycle. So it will put during winter, it will put the condenser from the side of the room and the
Mhm.
evaporator from the outer side. Okay, so the condenser now will reject heat. So if you are in winter, your room should be from this side, and what you care for then, the energy, the useful energy for you, will be the energy rejected by your system, which we call Q out. Then the COP of the coefficient of performance for this refrigeration cycle will be COP of
Q out over work electric.
heating. It will be Q out over W electric. So what you
Professor,
want
هو
to
بتكون
do,
heat
you
pump
want
صح؟
to, yes, you want to produce a heating effect. So you want to transform work into heating energy, and your useful heat is Q out, and your input is also W electric.
So, Professor, one question.
Yes.
So بهول the ACs يعني هلا in other countries like the Gulf they don't do heating. But here for example ACs بيكون condenser والevaporator بالindoor unit.
Look, هي الidea انت just you will change, you will circulate your fluid in the reversed way. Okay? Yes, يعني انت you switch the operation بس you switch the
بس
يعني you can
بس
circulate in
direction
the
flow.
opposite way تتقلب
اوكي.
تتقلب اذا بدك يعني من بيصير يكب لبرا during summer. okay. during summer بده ياخد من جوا، يعني نحن بيهمنا انه الايفابوريتر يكون during summer from the room side. يعني when you circulate your fluid إذا بدك you can just reverse the circulation. If you reverse the circulation it will you can operate in the opposite way. Okay.
دي. Thank you, Professor.
Welcome. Okay. Now if I want to relate W electric to Q in and Q out, what can I do? You know, for the throttling valve, what is nice about it is that you don't have loss of work. يعني it's an isentropic process. The throttling process is isentropic. Whenever we say isentropic, so we don't have any loss of work if you want. This is the advantage of using it because we want to convert the work completely into heat. So W is nearly zero in the throttling process. And because W is zero in the throttling process, then we can write that if we write the energy balance for this system, let us see what is coming in. What is coming in to the system is W electric because I'm putting electrical work to operate the pump. I have Qn is entering in the evaporator, so it's gain of heat, and the rejection is just Q out. So I can say that for the balance of fluxes, I have a plus W electric plus Qn minus Q out is equal to 0. So Q out here is the summation of W electric plus Qn. This is why I told you sometimes the COP can be larger than 1. Because here, you know, from this relation, you can find that Q out is larger than W electric. So here, of course, this will be larger than 1. While this one can be smaller or larger, it depends on the value of Qn. Okay? Any question on this?
Oh, thank you, Professor.
Okay, just one additional idea. If I want now to create another system, I can use mainly the same component, but I can replace here, if you want, I can replace the throttle valve by a turbine. Do you know what will happen then if I put a turbine?
We'll have some energy stored or generated.
Exactly. Will have work that is generated. So in case you have a different application, in case you want to generate work, okay, not heat, in the refrigeration system, the purpose was to extract heat or reject heat. Here you want to produce work. If you put a turbine, you can produce work because we have seen from the first chapter that the turbine can convert energy into electrical energy. Okay, it can convert mechanical energy, which is in form of work, into electrical energy. So if you want to produce electrical energy in this system, then what will be the input, you think?
The work تبول or the heat supply to the evaporator.
Yes, exactly. The heat in the evaporator. Very good. Yani, for example, you know that the majority of power plants that generate electricity, they work on this system because you can use the fuel to do combustion. Okay, let's say the combustion will produce heat. You can have the heat will be given to your fluid at the evaporator level, and then when you take the fluid through the turbine, during the expansion you have production of work in your turbine. And when you have the production of work, then you will have work that will get out, and the pressure of your fluid will be reduced. Then it will enter the condenser. Okay, and now the compressor will raise again the pressure. Okay, so that the system can operate again. And in this case, as we mentioned, what is useful will be the work at the turbine level. So W turbine, okay, is I want to produce a work at the turbine level. And in general, what we say we need to consider the net work, because we can use a part from the work on the turbine to operate the let's say the compressor. Okay, so the network, yes, exactly. The network here is the useful output, and we can say that we'll divide it over the energy that we are putting in, which is Qn, which is the energy of combustion. So here, a Q out will not figure out here in this relation, but we can use it to determine W net, because W net is equal to Qn minus Q out. So here we'll consider, like the thermal combustion engine, the output is the work and the input is heat. Okay?
Professor,
Yes.
هلا بدال الكمبرسor usually فينا نحط pump, right?
Yeah, of course. We'll discuss in the course in which case we put a pump, in which case we put a compressor. Okay?
Thank you.
Welcome. So what I want from you now, this is an overall idea of what we want to do in this chapter. In this chapter, we'll study cycles. Okay, so we'll learn how to use, let's say, thermodynamic tables. The majority of you know this, but don't worry, in case it's new for you, you know that for each chapter, I put for you some links. So especially for students that are not engineers, you can find in links like definitions of all new concepts. Okay, so you can go just click on the folder chapter 3 links. You have several links that will help you to know the main concepts that you need to use to solve such cycle problems. And also in the course materials, of course, I re-explain again how to use the thermodynamic tables to get the properties that you need to evaluate, let's say, the heat, the value of energy, enthalpy, internal energy, let's say, at each point of your cycle, and how you use them at the end to define the efficiency. Okay, so please, for this week, should go over videos of chapter 3. Now I will assign them for you, and hopefully next time we can start to do some examples together. Okay,
Deal, Professor.
plus also to practice more on chapter 2, you have an assignment on chapter 2, so to make sure you know how to deal with all concepts, you can try to do the assignment, and you have also the correction of the assignment posted on the YouTube playlist.
Professor, can I talk to you after class?
Yes, sure. Any question before we close?
دكتور بقدر أنا كمان أحكيك؟
Yes, sure. Yeah, I will just stop recording and we can discuss what you want.
Professor?